Hey everyone, before we go into the whole Vex thing, I want to talk about how Vex handles data. So more specifically, how wrangles handle data. Because what's very important, and actually something we already talked about, is that every point only knows, in the context of Vex, everything about himself. So if we create a point wrangle, for example, then that means that the code that we write in here will only run for each point separately. And that also means we can't directly access the data of all the rest of our points. So for example, I created a random attribute here called random, and it creates a number between 0 and 1. And let's say I wanted to create a sum of all those numbers on each point, then I could try something like this. I create a sum value of everything that is there. So I add to this constantly the current random attribute. And what we would hope to get is, a sum of all those numbers. But as you can see, every single point calculates the result as if there was only one point. And that is very important. Whenever we want to kind of calculate something that involves other points, we can't directly use that. For this, we would probably do something like this. We use a attribute promote, and this allows us then to, take the random attribute, and let's say we create a sum of all this and create a new attribute out of this, and we call it sum. And here, what comes out of this, and it doesn't work, why not? It doesn't work because you have to promote something. So what would make sense here, and what we usually do, is you save the result of all of the points in the detail. And here you can see there's a sum attribute now with, some kind of number that adds up all the random attributes together to this number. So this works. And if you need something like that, you have to do it before the wrangle or after the wrangle, and you have to do it in multiple steps to calculate an average or a sum or something like that. So that's very important. However, there are actually ways later on that we will see that you can actually do this inside of Vex, and namely that is with a for loop or PC open or something like that. But usually that's not recommended, because you either do this for every point, and that's kind of dangerous because you would run over every point for every point. So you would do a pretty expensive calculation for each point multiple times. It's better to do any kind of, multi-access outside of Vex and then, keep working with the result of that. Another option, like I said, is PC open. And this would basically mean you can read out of your surroundings and calculate an average from that, which is also pretty expensive, and you should only do it if absolutely necessary. So keep that in mind as a general rule. Every point basically only knows about himself, and with some help, what happens around him. Now that also means another thing. When we change the value of a certain point, even if we then read out that same point, we will not get the changed version of it, because all points are calculated independently, and only at the end the result is collected together. So what do I mean by that? Let's say we want to change some attribute on point 44. Let's say that if the point is 44, then his value gets the number, 6. All right. So all the values are 0, but of 44, there it is, the value is 6. Now, let's say after that, we run a code where we say, okay, if the current point number is 44, then let's say the value should be 10. And then we say for all other points, not only for the point 44, we say write the value of point 44, and we can do this way, and we will talk about this later, into the test. And what would we expect is that, okay, if the point is 44, his value gets 10, and then for all the other points, the test should be 10, right? But when we run this, you can see the test is always 6. So the number that was correct before this node here was running. So every point that runs this has no idea that this actually happened for point 44. So in other words, anything you do in here will only basically happen at the very end. You cannot assume that what you change in here will materialize itself during the execution. I know that's a bit abstract, but there are cases where you need that. So just keep that in mind. If you run into this kind of problem, this is totally normal and it's not your fault. It's just that the parallelization of this whole thing results in this, that only at the end result is collected. So you can't change something and then read it back in during the execution, at least not on another point. If you do that on the current point, then this is of course possible. So for example, you could set the value to 10, and then of course when you read that back into test, then it will be correct and both will be 10. But this only works because it's running on the same point, and this point doesn't need to know anything about any other point. The technical term for this kind of calculation is single instruction multiple data, so in short SIMD. So if you want to read this up, I link this on the side. It's a bit technical, but that's just the way VEX is calculated. All right, with that said, let's move on. Thanks very much. See you later. Cheers.